Now we will see the classes of P and NP. Classes of P and NP. What is P? P stands for polynomial time and NP stands for non-deterministic polynomial. So now here we are going to introduce the classes of P and NP of languages. Okay, Turing machine. So that's why we need to understand the definition. So definition here goes like this. A Turing machine M is said to be of time complexity T of n if the following holds. What is that? You given an input W of length n, M halts after making at most T of n moves. Okay, you supply a input to a Turing machine, and the length of the input is n, and this particular Turing machine, if it's halts after making at most T of n moves, then you can say that the Turing machine is said to be of time complexity T of n. Turing machine is said to be of time complexity T of n. Okay. In this case, M eventually halts, and recall that standard TM is called deterministic TM. Okay, standard TM is called deterministic TM. And a language L is in class P if there exists some polynomial T of n. So language L is in class P if there exists some polynomial T of n such that L equal to T of M for some deterministic Tm of M, machine M of time complexity T of n. Okay. Now construct the time complexity T of n for the Turing machine M for the following example. Okay, let's consider the example. I am here considering the example of 0 to the power n and 1 to the power n. Okay, and you know that how exactly the Turing machine works on 0 to the power n and 1 to the power n language. So it moves forward and backward. It moves forward and backward. Okay, and replacing the leftmost 0 by x, okay, and leftmost 1 by y. Okay, so leftmost 1 by y. So we require, because of this, because I have what? Replacing the leftmost 0 by x and leftmost 1 by 1. So that is why it require at most, so we need at most 2n moves, okay. Let me tell why it is 2n moves. So let's imagine 0, 0, 0 and 1, 1, 1, okay. Suppose the these two are changed already to xx, and this one is changed to yy. So now the leftmost 0 is this. To change this, it has to take n moves, okay. It has to take n moves, and to this leftmost one, it has to take how many moves? Another n moves. So maximum at the max, it is going to take 2n moves. Not in all cases, but at the max, in finding the leftmost 0 and in finding the leftmost 1, it is going to take 2n moves, okay, so that it can match 0 with 1, okay. Now this kind of a step need to be repeated, n times. That is, matching 0 with 1 need to be repeated n times, okay. So overall, if I have to say, so matching of 0 with 1 takes 2n moves, maximum it is going to take 2n moves, and this will be repeated, okay. Matching of matching of 0 and 1, okay, matching of 0 and 1 is done by 2n. Max at most, for that it is taking at most 2n moves, and these thing is repeated n times. These things are repeated n times because you have here 0 to the power n and here 1 to the power n. So this will be repeated. Matching of 0 and 1 you are going to take how many times? N times. Okay, so then therefore the number of moves taken by number of moves for accepting anything 0 to the power n or a to the power n or b to the power n, whatever, accepting this is at most 2n into n, 2n into n. Okay, so which is equal to 2n square, 2n square. So we can say that it belongs to order of n square. If for strings, what about the strings of not of the form 0 to the power n and 1 to the power n? For strings not of the form 0 to the power n, 1 to the power n, for that Tm holds with less than 2n square steps. For that Turing machine, if whatever you are taking, suppose if it is not in the 0 to the power n and 1 to the power n form, not in 0 to the power n and 1 to the power n form, then what happens? You can, or a Turing machine, you can halt, Turing machine is going to halt with less than 2n square steps, less than 2n square steps. Hence Turing machine, the complexity of Turing machine M is equal to order of n square for this particular language. Language is 0 to the power n, and for the language 0 to the power n and 1 to the power n, such that whatever. Okay, so it takes order of n square.